Hi friends, in this video let us look at when do we use these kind of tests depending on the situation. So the idea of this video is to make you understand that you cannot use any test by your whims and fancies. You need to understand the situation and the kind of variables you have and how you have measured them, and then depend on that you will decide which test you would use. So in this video I would be covering chi-square, ANOVA, ANCOVA, Ttest, regression, MANOVA and MANCOVA. So let's get started. We start with chi-square. So chi-square test is used when both your independent and your dependent variables are categorical, which means there are some categories. It is not continuous, it should not be metric, it must be non-metric, which means both independent and dependent variable has to be non-metric. Let us see an example here. You can see which holiday do you prefer. Now what we want to know is, does gender affect preferred holiday, which means gender is coded as categorical variable, coded as men and women, and the preferred holiday is again coded as beach and cruise. So what do we want to know? Well, we just want to know whether gender affects the preferred holiday, which means probably men would prefer to go to a beach on a holiday or would like to go on a cruise. Same goes with women. We want to see whether women on a holiday would like to go on a beach or on a cruise. So if this is the kind of study that you have, well, in that case, go ahead with the chi-square test. T-test. Well, when do we use a T-test? We'll have a look at the case study here. A researcher has maths marks of 100 students in which 55 are boys and 45 are girls. He wishes to know if there is a statistical difference in marks of boys and girls. Simple. So a researcher has 55 boys, 55 girls, and he has their marks in math subject. Now he just wants to know if there is a difference in marks of boys and girls, whether boys scored higher, girls scored higher. That is what the kind of test he wants to use. Now understand, the independent variable would be the categories, which means boys and girls. There is two categories, boys, girls. Absolutely fine. Independent variable. Dependent would be the marks that they have obtained, both the boys and the girls that they have obtained, and this will be in continuous. This will not be non-metric, it will be a metric variable, which means your dependent variable has to be metric and your independent variable has to be non-metric, which means it has to be in categories. We move on to ANOVA. The full form of ANOVA is analysis of variance. Now what happens in this? A researcher has maths marks of 100 students in which 30 students are from North India, 40 from South India, and the rest 30 from East India. The researcher is interested to know if there is a statistical difference in their marks. Simple case study. Independent variables are the students that are either from North India, South India, and East India. Now, how many categories are there? I'm talking about the independent variable. There are three categories. What are those three categories? North India, South India, and East India. Okay, independent variable has to be in categories, but the categories has to be more than two. If it is less than two, please go ahead and use T-test. If you have categories which are more than two, you have to use ANOVA. That's the basic difference between ANOVA and T-test. People often get confused here. T-test, when your categories are only two. We just saw an example, males, boys and girls that we saw. There's two categories, boys and girls. So go ahead and do a T-test. ANOVA would handle those studies wherein categorical variable, independent variables are more than two. So in this case, it is more than two. So we use a ANOVA. Independent variable categorical, and your dependent variable again becomes your metric, which means it's continuous data. Maths marks would always be in continuous. So we will use an ANOVA here. Okay, what about regression? Regression basically are two types here. We are seeing linear and logistic regression. Linear regression, we'll see a case study. A researcher wants to know if there is an effect of IQ on grades obtained, which means probably researcher has data of some respondents with their IQ scores, and he wants to know whether this IQ score has any effect on the grade. If you have higher IQ, will you have more grades? If you have lower IQ, will you have lower grades? The point is both independent and dependent variable has to be in metric. Okay, it should not be any categories. It should not be in any in any other forms. Like in this case, IQ becomes the independent variable and grades become the dependent variables, and both are measured in your scale variable or continuous variable or metric data. Okay, now linear regression is done. Let's go move on to logistic regression. A bank hires a researcher to suggest if a particular customer, let's say Mr. Sohan, will pay back the loan or default. So what does the bank wants to know? Whether Mr. Sohan will he default or will he pay back the loan? They just want to know this, which means that there is categories: default or will pay back. Okay, two categories. So when your dependent variable has categories, two categories, and your independent variable will be many factors like for example the probably the age of the customer, the income of the customer, okay, where is he residing, in which part of the country is he residing, many other factors. So those will be the independent. So independent variable can be many, but dependent variable has to be in categories. Okay, so here the categories are how many? Two. Whether he will pay back the loan or he will default on the loan. That the bank wants to know. So the bank has hired a researcher to do this. If you want to do such kind of analysis, you would go for a regression, but here you will go for a logistic regression, where your dependent variable will be categorical. And the linear, what happens? In linear, both your independent and dependent are both not, it's not categorical, it's metric data, which means continuous data. Okay. We go for ANCOVA. ANCOVA stands for Analysis of Covariance. Okay. Now here you see that we have independent variables and we have two independent variables here, and we just have one dependent variable. The first independent variable is level of education, and the level of education has three categories: high school, college degree, graduate degree. So the first independent variable has three categories. All right. What about the second independent variable? It's a covariate, which means numbers of hours spent on studying. This will be continuous. Okay, and the first factor, that is level of education, will not be continuous, it will be categorical. Okay, and what about the dependent variable? Dependent variable is test score. So the researcher wants to know whether what the level of education and how much time you study, what effect does those two factors have on your test score. So your test score becomes dependent, and the level of education, number of hours spent on studying, becomes independent. And the important point is that the independent variables are mixed, which means one is categorical, the other is continuous, and your dependent variable is continuous. So such kind of situations is handled by ANCOVA, that is analysis of covariance. What about MANCOVA? Well, MANCOVA handles such kind of situations. As you can see, we have pretty much same situation as we have seen earlier. The independent variables are two independent variables. The first is having three categories: high school, college degree, and graduate degree. And the second independent variable is hours of study. So first independent variable is categorical. Second independent variable is continuous. But the dependent variables are now two. The dependent variables are uh, test scores and annual income, and both of them are continuous in nature. So we can say MANCOVA handles such kind of situations where the dependent variable is more than one. Okay, we just saw in the previous example that we just had one dependent variable, and that was test score. But if you want to know the test score and the annual income, okay, then in that case, this would be handled by MANCOVA. So MANCOVA handles those situations where your dependent variables are more than one and they are continuous, while your independent variables are mixed. Okay, mixed means that one of your independent variable might be a categorical data and the other can be a continuous data. Let's move on to MANOVA. Now MANOVA, what is this? Let's see. Again, the same thing, we can see independent variable is just one, okay, and that has a categories. case, have a high school, a college degree, or a graduate degree. And what we want to know the level of education has any effect on the test scores and annual income. So again, the same thing. Independent variable is just one. Dependent variables are still two. Okay, and dependent variable continuous in nature. Independent variables is categorical, which has some categories. Okay, non-metric in nature. Such handle is done by the MANOVA. I hope this video was interesting and you got to know as to in which situations do we use what kind of test. What I would encourage is you could just take a screenshot of the slides that I had in my video, and you can just pause for a moment, and whenever you do any research, try to find out where my research fits. Now, generally I've seen your research would either fit in regression or in chi-square or probably in ANOVA are at the maximum T tests. You won't go for ANCOVA, MANOVA, or MANCOVA. But if it does, well, go ahead and please use the test. I would be making future videos based on these tests also. I hope you found the video interesting. If you like it, please subscribe to my channel, like it, share it with as many friends as possible. Thank you so much.